I was like, Daspedia is hit. It's got some moves there. But I realized it's tech talk. Not good. AI, math, deep learning, what's up with that? You guys ready for some math? No. Okay. All right. So, everybody's talking about AI this and AI. Today we're going to try to scratch the surface of what AI is. And since I cannot see anybody because of the lights, but let's start by saying, who in the audience, just by show of hands, who's using AI every day? That's it? Nobody's using ChatGPT? Or Copilot? Or Bard? Any of these? Okay, out of those who raised their hand to say that they're using AI, how many of you is using AI for wireless? Oh wow, nobody. Oh, somebody. Oh, there. That's great. Right, so we're gonna cover a lot on that today. So, good morning. My name is Amr. As people like to call me the AI guy. Deep dive into AI. Started Omega Wireless 18 years ago, focusing on design and optimization of venues, critical venues, Super Bowls, airports, theme parks. We try as much as we can to optimize these venues and make sure they are the best performing and deliver the best quality to our customers, being the carriers and whatnot. We're probably the first, I want to say one of the first, maybe the first, to use AI for optimization for the in-building space. I myself been in this industry for 30 years. Oh my God, I'm old. 25 years of those I've been doing AI. So optimization all the way back in 1998 when I did my master's degree, frequency plan, GSM days. Anybody remembers any of these? We're really involved in AI. Did a lot of work through my research, through my PhD, a lot of patents, a lot of papers. My focus was really to use AI for wireless. I mean, a lot of people are talking about how AI couldn't have happened without wireless. I mean, when you're ChatGPT, if your phone is not connected, you're not getting results, right? So this is how wireless is really delivering AI to customers. What about the other way? What about AI serving wireless? We're going to talk about that today. All right, so what's AI? Last few days, it was a roller coaster. $500 billion of Stargate. Yay! And a lot of jobs and a lot of work to do, right? And then yesterday, the whole market was wiped out. $2 trillion gone. Because there was an advancement that just happened, and what is going on here? All right, so I'm going to use this picture for a while, so just bear with me. That's my dream car to the right, on the left. Hopefully we can get one of these one day. But basically, let's break down AI so we can understand what is AI, how does it work, what are different types of AI, because it's really confusing when we start talking about AI. So generative AI is the most common, a lot of people are using. So large language models, ChatGPT kind of thing, NLP, natural language processing, understanding what people say or generated. Deepfake, you create deepfakes, created a lot of these for our ads. You could generate pictures, you could generate videos. And this picture to the right, obviously, is one of them. Machine learning, this is one major branch of AI. When you understand text, you understand pictures. Loading up AI again. Vision, self-driving cars. Look at x-rays, looking at documents, understanding what are the documents. We built a solution called Expert AI where we look at trouble ticketing systems and look at KPIs and kind of like correlate them and learn from them to find the root cause for failures in elements based on the KPI signature that we can see. This camera right here has a tracker where I move, it moves with me. That's part of recognition, that's part of AI. So a lot of stuff around us is doing AI. Another type of AI is optimization. This is where you have a problem and you try to maximize your performance or minimize your time. Like when you route, you want to go from the hotel to your office or the meeting point. You get a lot of routes. So the job of Google is to route you to the fastest route or the least expensive or the most economical. So these are all types of optimization and AI as well. And within these, we have genetic algorithms, have simulated annealing, and we have a couple of patterns on this as well. Now, what about wireless? What about inbuilding? What does it look like a snail? So your AI is moving with the speed of a Corvette, while wireless, especially inbuilding, we're not using AI. Without AI, we're still in a snail pace. What can we do to do that? That was our biggest challenge when we started diving into the wireless network. And that's why we actually came up with AI optimized networks, or what we call ION. So with that, I really want you to watch this video.
Are you struggling to cope with wireless network traffic demands and meet performance KPIs? Is it getting harder and harder to manage so many network layers? 4G multiband, 5G, C-band, millimeter wave? Are you spending weeks or even months and still can't achieve carrier KPI approvals? Or, as a carrier, do you find it challenging to optimize your wireless networks to improve customer experience, all while dealing with limitations of CapEx and OpEx budgets? The answer is ION. Omega Wireless introduces Artificial Intelligence Optimized Networks, ION, a service melding years of venue and HetNet design expertise with cutting-edge patented AI technologies and algorithms. ION navigates to the best solution out of trillions, changing the game for antenna selection and optimization. With ION, we are able to reduce the time to run simulations from hours to a fraction of a second. Then, the algorithm will navigate to the best possible solution for best possible customer experience. Proven in the field, ION has elevated major stadiums, airports, and renowned theme parks to new levels of capacity and quality, securing carrier approvals and doubling performance. Best part is that this improvement resulted in significant savings in time spent and CapEx deferred. Let Omega Wireless take you to the future of HetNet design and optimization tools with ION. Experience unparalleled improvements, meet your KPIs faster than ever before, and save money on network upgrades. Step into the future with ION.
Alright, so when we started doing optimization and design for wireless networks, especially inbuilding, we faced a few challenges. First one was, most of the simulation tools run forever. It takes forever to run a single change. So just taking one example of one of the design tools, and the timer is right at the bottom. Just taking one antenna, changing the tilt, going from 35 to 50, just trying to play with it. It takes forever. It takes minutes, sometimes hours, depending on how heavy the project is, how good your machine is, and so on. This is time and cost prohibitive. It makes it so hard to do it. So we'll let this run. We're doing it in fast forward. I'm going to show you what we did with ION. So we went from running in hours to running in milliseconds. So what we're doing actually, I'm going to start running the video. Basically, it will show you how you're going to pick a tilt or an azimuth or a power, change it, and the result is instant. You get the instant change impact, or even changing the antenna. So on the left, it took us an hour and 7 minutes. Oops. Go back here. There you go. And one more. There you go. So you change the tilt, and instantly you get the impact at the bottom. You can play with the tilt. You can slide your tilt back and forth. You can slide your azimuth back and forth. You can slide your power back and forth. Every change is instant. Takes a few hundred milliseconds and gets done. You can even change the antenna altogether. You can see instantly how this is changing. So you're not spending hours changing one change to see what the impact is. Now, very important also to see that you can also change antenna patterns altogether. I don't like this antenna, what if I use a different antenna? And how do I measure the output? You could look at your RSRP, you could look at your SINR, you could look at your capacity, which is a big thing we're going to talk about in a second. So in the few hundred milliseconds, you're getting the full picture of what's going on. You could assess and evaluate if this choice is the right choice for you. All right, the second challenge was, so we went from hours to milliseconds. So by the time you do one change in a typical prediction tool, you would have run thousands of changes with iron, exploring all of this. And basically, this is the engine that we're running with. Second problem is, whatever we do, we're doing it manually. We're trying to find the best solution. There was a few of you who said they're ready for math. Anybody? No? Okay. We still have to do it. So I wanted to imagine 100 antennas in a stadium. Each antenna has 10 degrees of freedom, or we call them choices, for tilt, and another 10 for azimuth, another 10 values for power. So each antenna has 1,000 combinations. Imagine the next antenna has another 1,000, another antenna has another 1,000. What is your solution space? How many choices do you have? 100, 1,000, 100,000? It's actually 1,000 to the power of 100. That's 10 to the power of 300. Something like the math or scientist in the Back to the Future. Gigawatt. All right. So basically, if you're looking at tilt and azimuth, if you're just changing these two, trying to figure out what your best sonar is, you can be at the blue point. You're not doing so well with your sonar. You might do some manual work to get to the yellow or green, but you will never get to the red because it takes forever. And remember, each change takes an hour. So by the time you do the third change, you're done. And it's so interleaved, so it's really hard to find them. With iron, we have a patented algorithm that does simulated annealing with block coordinated descent. Forget about the terms. It does get into the global optimum. So what you get is the best that is possible. As a result of that, we actually implemented this solution in several stadiums, and we did it for a tier 1 carrier, and they are with us today, and we spoke last year as well. And we were able to actually double the throughput on an existing system. When we implement the changes, you can see the real impact on real customer experience. So understanding where the users are, and also improving sonar and improving throughput. These are real results. So you can squeeze a lot out of your existing venue before you decide to do an upgrade. How much is that worth? Millions of dollars of upgrade that you can push out. So that's a huge improvement. The last challenge we looked at is most of the tools that we deal with today, they only look at your RSRP and maybe sonar. They never look at capacity. They never look at how many sectors do you have. How much is that going to impact your throughput? What is the traffic balance between sectors? And with ION, we're actually looking at where the users are, what is the capacity need, and we steer the capacity and performance to where these demands are. So in a major theme park that we implemented, you're interested in improving Main Street, not the back of the house. You want to do where the users are, not in the middle of the lake or in the middle of the forest, in the middle of the parking. You really want to optimize where the users are. And by implementing this, we were able to get up to 60% improvement in a major theme park in Anaheim. We don't know about that. All right, so how do we do it? And we're running out of time. So we basically take whatever design that you have, IUAV atoll, Rampan, whatever you have. We create our own digital twin. So for example, this is Formula One. We built the whole of Las Vegas. The strip, we built it into our digital twin, and we were able to optimize for throughput. And the best thing is we're able to double the throughput. Again, this is macros, small cells, in building, outdoor, cows, everything. We're able to double the throughput on the stands by putting the right server with the right capacity in the right place. All right, so what's in it for us? For carriers, for OEMs and 3POs, we're able to deliver faster designs, get your approval quicker, minimize the work in the field. You're not spending 6 to 8 weeks in the field trying to optimize manually until this antenna, until that transmitter. You get the best possible quality, so you cannot get any better. You're not wasting any time on that. And the best thing is you're maximizing your ROI for whatever deployment that you do in there. Last but not least, we also implemented machine learning and optimization algorithm to do what we call ION real-time, where you're able to change parameters real-time, whether it's your remote electrical tilt or handover parameters like CIOs. We implemented this on a tier 1 in a major market. We're able to get 45% improvement on throughput just by shifting traffic between sectors. Optimization is not just about sonar, it's also about capacity, where you put the users in the right place and get the improvement. Gosh, that was 6G. That was too fast. All right, so congratulations. You just graduated the crash course of AI. Give yourself a hand of applause. Thank you so much. We have all the data over there. If you guys are interested to talk more about crazy AI or the crazy drug. Yeah, thank you so much.